Okay, everyone. This is the second topic, arithmetic sequences in series. We'll do this one in two parts. Remember to read the notes at the beginning of the document, and you can always pause whenever you want to take a break. Here it says, write the rule for an arithmetic sequence with the 19th term being 48 and the common difference being 2. Remember, the common difference is how much, in this case 3, is added to each successive term. So let's see. We'll start with the equation that's given in the notes. This is the first term plus n minus 1 times the difference. So in this case, we're talking about the 19th term, so n is 19. And when you plug in 19, you get 48. So here's what we got. We'll do a little simplifying real quick. This looks like 54. So it would appear that the first term, first term is negative 6. So that means, let's see, what are we trying to do here? We're going to read the question, make sure I do exactly what the question asks. It says write the rule. Okay, so let's see, rule. Okay, that would be an okay answer, or so here are our two answers, and this is the rule, and this is the rule for a arithmetic sequence whose 19th term is 48, and the common difference between each term is 3. All right, cool. Let's keep going. Oh, I forgot to start my timer, so I'm going to do that real quick. Okay, let's go to 2. Two terms of an arithmetic sequence are, okay, the 8th term is 21, and the 27th term is 97. Find a rule. Okay, this problem is going to use a system. So let's see. Well, we're going to start with this. The 8th term is 21. So I'm going to plug in the 8. So 8 minus 1 is 7. There's my first equation. Second equation, 97, that's sort of a big number. Do not like that, I'll tell you. So 27 minus 1. All right, there are my two equations. So let's use the system. Okay, so let's put the 97 on top, because I do not like dealing with negative numbers if I can help it. Okay, and I'm going to try to not be looking in so you see my head. It's so embarrassing. So let's see. It would appear that we're going to do a little bit of subtraction real quick. The A's cancel, obviously. So 4 times 9 is a 6, so yeah, it looks like 4. Common difference is 4. Are we done? I don't think so, because we have not done what the question's asking. It says find the rule. Okay? So let's see. Rule. Oh, you know what? We have to find the first term. So let's find the first term. So I'm not gonna plug into the equation with 97. That number's too big. So let's plug the d in over here. So find a sub 1. So looks like -7. Okay, so we have, I'm going to write it a little more clearly here. So we have a sub n equals -7 plus n minus 1 times 4. Done. If you want to expand that out like we did in example 1, you are welcome to do that. Remember, you can pause at any time. Okay, now we're going to prove that the sum of any nth number of terms is n times the first term plus the last term divided by 2. So a sub 1 plus a sub n divided by 2. Okay? So we'll do this problem, then we'll take a break, and then you can look at part 2 of arithmetic sequences and series. Okay. The sum of, say, the nth number of terms of an arithmetic series would be this. First term plus the second term plus the third term dot 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 plus whatever the last term is. Then if we do the same kind of equation, but we reverse the terms. If we say we start with the first term, sorry, I meant to say the last term. Now, the second to last term, based on the last term, would be the last term, a sub n, minus d, going backwards, plus a sub n minus 2d. For example, if this was 10 and d was 2, you'd have 10, 8, 6, plus dot dot dot. The last thing you would be adding would be the first term. So here, starting with a sub 1, we're adding d, adding 2d, adding 3d, 4d, 5d to the last term. The same idea, starting with the last term now, a sub n, take a sub n, subtract d, then subtract another d, then another d, then another d, and your last term will be a sub 1. When you add s sub n and s sub n, which again is the sum, you're going to get this. 2 times the sum. Now, depending on how many terms you have, that'll dictate how many pairs you have here. Let's see, a sub 1 plus a sub n. Notice that that's this numerator. And you have to figure out how many pairs of terms you have. So we're going to say we have n pairs. Then, to get what we're trying to prove, we're just going to divide by 2 real quick, and we're going to get this. So the sum of an arithmetic series is going to be the number of terms times the first term plus the last term divided by 2. Yay! All right, guys. We'll take a break right here, and we will come back for example 4 and example 5.